Okay, today we are going to take what we were talking about with integer exponents and we're going to extend it to multiplying things that have exponents. We're going to learn some properties of multiplication with exponents. There's three rules we're going to talk about today. The first one is this one. To multiply powers with the same base, if you'll remember, the base is the big number with the exponent on it. The base remains the same and the exponents are added. Here is an example. Okay, I have 11 to the fourth times 11 to the third. I can write this out all in pretty expanded form. 11 to the fourth means 11 times 11 times 11 times 11. And then times that I have to do 11 to the third, which is 3 more. Well, I don't want to write this out every time, so I had to come up with a shortcut. If you count these up, there are 7 11s in a row here, which is the same thing as 4 plus 3. So my shortcut is just add the exponents. So this is the same thing as 11 to the 7th power. So you leave the base alone, you keep the 11, and you just add up the exponents if you're multiplying things that have the same base. So the next example, this x to the 7th times x to the negative 5th. My base is x, and then my exponents are 7 and negative 5. Well, when I add those, 7 plus negative 5 is the same as 7 minus 5. I just get x squared. So the negative is taking care of itself. I don't have to worry about that rule from yesterday where I had to move it and put it in the denominator. It takes care of itself when I add the exponents. Now, this next problem, my bases are the same in that they both have an n, but the n's have coefficients in front of them. When you come across a problem like this, you keep the n, but you have to multiply the coefficients, the big numbers in front. So I have to multiply 2 times 5, which is 10, and then I have to add the exponents. So you multiply big numbers, add little numbers. 4 plus 6 is 10. So that comes out to 10 n to the 10th. The base is the n. The 2 and the 5 are coefficients I multiply. The 4 and the 6 I have to add. Okay, next example. This is the same thing. It looks, and I mean it's longer, but my bases are still the same. I have an x and a y and a y, and both problems have an x and a y. First, multiply coefficients. 3 times negative 5 is going to be negative 15. Then for my x's, I'm going to add the exponents. 2 plus 3 is 5. And for my y's, I will add the exponents. Now this one, since you can't see it, it's a 1, so I'm going to have to do 1 plus negative 4, which is negative 3. Now since I have a negative exponent, my answer, I cannot leave it that way, so I have to drop this into the denominator. The negative 15 x to the 5th stays up top because they're all positive exponents, but the y drops to the bottom and becomes to the positive third. These are the same thing. This one is just the simplified version. Okay, next one. My base for all of these is 2. So I'm going to put my 2. And then I have to add my exponents. This one has a 1. Well, I have to do n plus 2 plus 1. And I have to add all that up, putting like terms together. So I have 2 n's plus 3. So this is the same thing as 2 to the 2n plus 3. I just put like terms together within the exponent, and that's perfectly okay. Okay, so that's multiplying powers with the same base. Keep the base, add the exponents. That's rule number 1. Rule number 2. We call a power to a power. Make it so you can see it here. To find the power of a power, you keep the same base, but you multiply the exponents. Now, the difference between this and what we just did is that you will notice these just have a multiplication sign in between them. These have parentheses, and outside the parentheses is another exponent. So when you see a problem like this, you have a power taken to another power. In other words, I have an exponent to an exponent. And so when this happens, you multiply the two exponents together, because this is the same thing as saying y to the 6th times y to the 6th. And if you'll remember from the rule we just did, same bases, add these. This is y to the 12th. But if you'll just look, shortcut, 6 times 2 is 12, which is where y to the 12th came from, because we do not always want to write it out. But this is why we multiply the exponents. So this next one, I have x to the 4th to the negative 2 power. I'm going to multiply the exponents. 4 times negative 2 is 8, or negative 8. So I have x to the negative 8, but negative exponent rules are going to apply. I have to write this as a fraction, and I put this in the denominator so that that 8 becomes positive and I don't have a negative exponent. Okay, I'm going to do these next two examples backwards. I'm going to do this one first. I have 4 to the third power. We're going to multiply exponents first. So 3 times 3 is 9, so this becomes 4 to the 9th power. Well, I can't leave it like this. I have to actually go multiply it out and find out that 4 to the 9th power is actually 262,144. They are the same thing, but if you want it in simplified form, you actually have to tell me what 4 to the 9th equals. Now this one is going to involve the rule we just learned and then the rule we started with. So we're going to have to, you see here, I have parentheses with an exponent outside. So I have to multiply these exponents. This c to the 5th, I'm not going to use yet. But this, I have to multiply the 3 times the -1, which makes that a -3. Now, this problem looks like the ones we did on the previous page, and so I have same bases, which is a c. So I'm going to add the exponents. 5 plus -3 is 2. And so my final simplified answer is c squared. Okay, so powers with the same base, add the exponents. A power taken to another power, so I have an exponent to an exponent, multiply the exponents. So rule number 3. To find the power of a product, so now I'm taking the power of something that's multiplied together. I have to apply the exponent to each factor. That means each part of my multiplication problem. This is sort of like distributive property. I'm going to distribute this exponent to everything in the parentheses. So I'm going to distribute it to this x, and I'm going to distribute it to this 5. So this becomes x to the 5th, y to the 5th. And that's all there is to that problem because I distributed my exponent. Now with the next example, it's a little more complicated because I have coefficients and I've got variables. I've got all kinds of stuff going on, but this 3 has to be distributed to the 2 and to the x squared. So this becomes -2 to the 3rd power times x to the 6th power because I multiply exponents like the rule we just learned. And then times, now I've got to distribute this 2 to the 3 and to my x. Well, so now I have 3 squared x squared. So now I've got to start simplifying. The first thing I got to do is figure out what -2 to the 3rd power is. Well, 2 to the 3rd power is 8. Because this is not in parentheses, I have the little negative. That makes this -8 x to the 6th times, and 3 squared, you know, is 9 x squared. So now we're going to multiply our coefficients. So I'm putting a bunch of rules together here all at once. I distributed my exponents, then I have to add my exponents. Okay, so I've got to do all this. -8 times 9 is -72, and then I've got to add these exponents because I have the same base. They're both an x. So 6 plus 2 equals 8. So there's my simplified answer, is -72 x to the 8th. So this put several rules all together in one. So let's look at the next problem. This is in parentheses, and I've got a product because I have 2 times x, and it's taken to a power. So I've got to distribute this 2 to everything in there. So I end up with 2 squared, and then I have to multiply these exponents so I get x to the 6th times x to the -4. Well, now I still have like bases because I have an x and I have an x. So I can still go ahead and follow my rules from before. I'm going to end up adding the exponents, but let's first find out what 2 squared is. 2 squared is 4, so I have 4x to the 6th times x to the -4. Well, since I have like bases, I can just add the exponents now. Okay? There's a 1 in front of this x, even though you don't see it. And so when you multiply your coefficients, 4 times 1 is just 4. Your base is x, and then when you add exponents, 6 plus -4, it is squared. So last example for this one, I've got to take this 2, and it has to be distributed to everything. Okay, so I end up with 1/5 squared. I'm going to put it in parentheses because I got to square all of 1/5, not just part of 1/5. Then I have to multiply these exponents. So this becomes c to the 14th, and this becomes d to the 6th. Let's go ahead and do 1/5 squared. 1 times 1 is 1. 5 times 5 is 25. C to the 14th, d to the 6th. There is your simplified version of that expression. So we've covered 3 rules, all pretty fast. Back up real quick. The first one, to multiply powers with the same base, you add up the exponents. So if they just have the same base and you're multiplying, add the exponents. Multiply coefficients, add the exponents. If you have a power to a power, so you have something in parentheses taken to a power, you just multiply the exponents. And if what is in parentheses happens to be a product of more than one thing, you distribute that exponent to everything. So this and this are pretty much the same rule. You just have to remember that if it's a product in parentheses, that everything gets the exponent, not just the last thing you see.